All right.
Chapter 9, 10,
So, quizzes are great. They're in the book. Some of you did fairly well. Some of you had some interesting approaches to things.
Is there a class average?
Yes, there is a class average.
What is it?
Not off the top of my head, I don't know. All right, so my office hours today. Pretty much all day I'll be here. Tuesday, I gotta go to Cherokee Trail. Don't worry, I'll wear my Creek shirt. I mean, there's a football game against them this coming weekend, right? Friday?
Yeah.
Wednesday, I should be available all day. Thursday, all day. Friday, I do have a meeting from 10:30 to 1:30 roughly. Gotta meet with a bunch of doctors. Nothing's wrong though, it's about my med class, so that's what I got. So if you do need to take that opportunity to finish up the quiz, or if you have to take the quiz, remember, first period I'm in the office across the hallway. The rest of the day I'm in that 2-story building right across the parking lot, office 200. So just know that and just come on in. Cool? So we didn't have any homework over the weekend, which I know most of you cried yourself to sleep with that. Right? Got bored. You're like, man, if I just had some math work, man, I could be in. Got a question, Reese? Or are you just stretching?
Yeah, I fell asleep comfortably on my new futon.
Futon.
Yeah.
Love it. Is that because there was no math homework?
Yeah.
Gotcha. I'm glad I helped you sleep.
You made it all
Casey? Perfect. All right. So here we are. Yeah.
So, according to your schedule, does this mean we want to test this week?
I don't think we do have anything scheduled.
Oh, my God. All right.
Will that help you sleep easier too?
That will. Thank you.
Yeah. Yeah. I'll get you your stuff. All right. You guys ready? You guys set? So, Reese, to kind of tentatively where we are at, we will have a test. So it'll be our first unit test. Let's see, we have this week will be fine. That in 2.5 weeks. And that's when our next opportunity to show how good of a teacher I am will be provided for you. Make sense? All right, so scientific notation, some of you struggled. Okay? Please don't let it get behind you. I'm happy to have starting tomorrow, we'll do some warm-up questions that'll link along with scientific notation. Hopefully you can make the presentation from that. Yeah?
I think it's kind of sad that more of the test grades are bigger than a lot of the homeworks, and we do put most of our effort into the homeworks, but then we'll only get like a quarter fraction put in the overall grade.
Okay.
So it's kind of like I wish the homeworks could be like more points.
Here's the problem with that, though. I'm not really checking the homework. I just glance to see that you tried, where I'm checking the quizzes and tests. Right? So when I come by going, it looks like you got it, and like, you know, you just scribble down as fast as you can. I'm kidding, not you, but other kids. But so that's why.
All right.
Sorry about that.
That's okay.
So that's long and short. All right, let me get rid of this stuff. Clear the ink. Let's do a little. That should work. Oh yeah. All right. Working with linear expressions, number 20. Number systems, radicals, and rational exponents. So if you are a note taker, do some notes. If you're not, just chill, watch, enjoy. And we are almost 5 minutes into this lecture already, as far as the video goes. Number systems, radicals, rational exponents. Okay, so let's take a path back to elementary school. You with me on this adventure? This is where we still had built-in recess. We had nap time. I mean, just Kitty, I'm glad you didn't say your second period, but I love it. All right, so let's talk about some of the number systems. So when you had gotten into your earlier years of school, you might have walked in and right above the board they might have had, they probably had the alphabet, and then they also had the numbers. And yeah, you had some sort of number line. And then just to make kids stay interested, you had like 1 red crayon and 2 apples and 3 little play toys and 4. And that allowed kids going, oh, look, I can count. So you started these number systems, and when it started with 1 and went to however much your teacher had wanted to go across your board, usually went up to 25. Some people might have went up to 100. Some people might have wrapped around the room, and their teacher was way beyond. But if you started with 1, these were called the counting numbers. I mean, things you can count. How many do you have? I have 1. Good. And you go to your friend, how many brownies do you have? I have 2. Why do you have 2? Because I broke it in half. No, I have 2. And things like that. And then as you advance a little bit further, they started the number system with 0. Oh, they started out with 0. You were in advanced class then. But they called that number system the counting, or the whole number. So you had the counting, and then you added 0, and that became the whole numbers. And your teacher might have said, whole has an O in it. That's where you start with the 0. And you're like, okay, great. Okay, and so you only had 2 number systems to really worry about in elementary school up through maybe 2nd grade. And then somewhere in there, they probably put something in there that had the negative numbers, where you realized 0 was in the middle. And then you probably went to the fractions and the decimals. And there was different counting number systems with that. Okay, and then they told you you have rational numbers and you had irrational. And so a rational number, that's an L, it's supposed to be an L. A rational number is basically any number, and this always confused me as a kid, any number you can make is a fraction. As like, well, you can put any number over 1 and it's a fraction. Go, good. And my teacher would be like, good, Chris, you're smart, idiot. And keep going. And if your name's Chris, that was directed towards me, not towards you. But then they introduced something called the irrational numbers, which floored me. Because it's like any number that you can't make a fraction. You're like, but you could put it all over 1. And the teacher's like, okay, good, Chris. No, it's over 1. Chris, you're okay. No, what? Chris. Any number, and then the teacher, because, kids like me had to make up some alternative rule. And they just said, this is any decimal that never repeats. It doesn't have any pattern. Like pi. And then I read, it's like 22 over 7 is pi. Yeah, that's close. No, that's what I heard. Because I read like Highlights magazine and Ranger Rick and things like that. So those are just some of the number systems. So the irrational numbers are the ones that is a decimal that goes on and on and on forever. So numbers like the square root of 2, that's an irrational number. That is a decimal that goes on forever. It never repeats. There's not a pattern to it. Pi is also 1. Square root of 3 is 1. Square root of 5 is 1. Square root of 7 is 1. Square root of square root of 11, square root of 10, things like that. Those are all irrational numbers, meaning if you were to write out the infinite amount of decimals that are there showing no repeat in the decimals, there's nothing that you could put over something else to give you the fraction. So irrational numbers are just things that go on and on and on and on forever and ever and ever. Okay? So that's basically where we're starting to go with these. And so we're going to introduce a couple of more number systems. Everything that you've ever dealt with in this class goes along with something called the real number system. Now, how dare math people, call something real, and then they're calling them non-real, but non-real are also called imaginary numbers. Now, what sick mind out there said, these are real numbers. Well, of course they're real. I can see them. And then you have imaginary going, what, like, Alice in Wonderland? Imaginary? No, they name two different names like that for some reason. So the real numbers are a really big thing where you have the integers, the rational numbers, the irrational numbers, the real numbers, and then you get to the non-real numbers. And really the only place in high school where you'll see numbers that are not real is when you have the square root of a negative number. Okay, the negative is underneath the square root sign. Now, the difference between that and this, where is the negative sign in relation? Yeah, under the square root. It's either under the square root or outside of the square root. This just means the negative of whatever the radical is, or the square root, and this is the square root of a negative. Okay? The square root of negative doesn't make sense, but where the square root of negative number starts taking place is when you get into further on math classes. You guys have all probably seen the movie Jurassic Park, and you have the guy who's the mathematician. He talks about chaos theory, and you have a droplet of water that follows the path of your hand one way or the other. That's a really bad representation of chaos theory because chaos theory is much more expansive than talking about the way a driplet of water on your hand would go. Other people say, well, it's like the butterfly effect where a butterfly flaps its wings in Brazil and you get a hurricane in Florida. Okay, again, you're taking something way too extreme. Basically, non-real numbers or imaginary numbers deal with the inner dimensions of math. And we talked the other day about 1 dimension, 2 dimension, 0 dimension, 1, 2, 3, even showed you 4 dimension. This is like the inside of that dimension, like the 3.62 dimension, which is ridiculous to think about. So that's kind of where these are going to, and don't worry, we're not even heading on that pathway yet. So those are just some things to know about. So real numbers are the big number system we're dealing with that you've dealt with all along, and then from here on out, we will not deal with a negative underneath the square root and say no solution or does not exist. It does exist. It is a solution, and we will be getting there. All right. Use your calculator to find the following. What does the exponent 1/2 mean? Can we write this in a different way? Okay, so I want to bring something up. Let's go with my calculator. I'll bring that up. Let's see if we can load it without crashing the computer, which is always possible. So if you have one of these fancy-dancy calculators, you can get it out, or if you have your regular calculator, you can also get it out. All right. Ooh, looks fancy. All right. So large screen, history, no, I'll do large screen. Let's do this. Help. All right, so let's talk about this graphing calculator. Okay, if you have it, fantastic. If you don't have it, things are going to work, regardless if you have it or not. So if I wanted to have something, and I believe this was showing something to the 4 to the 1/2 power, let's see how the calculator would accept that. So I'm going to type the number 4. It should work, except when I
Put the marker down.
put the marker down. 4. I don't want that. There we go. We'll make it work. There we go. 4. Great. Highlight it. Oh my gosh, are you kidding me? Ideas? Nope. All right, let's just do this. We will use 4. All right. Woo. Got it. All right. Is this going to work? I'm going to use this little caret key, and that's going to be 4 raised to this. Some of the calculators will actually have the caret key on there, but I want something raised to the 1/2 power. So I'm going to use open parentheses, and 1/2 is the same thing as 1 divided by 2. And I'm going to close the parentheses. Any guesses what 4 to the 1/2 power would be? 2. We get an answer of 2. Okay. So let's bring this back up. Let's take a look at this. And then we have 16 to the 1/2 power. So we use the calculator. If I go 16 caret, open parentheses, 1 divided by 2, close parentheses, hit enter, and we get 4. And then we get 32 to the 1/2 power. It says 36? Oh, you guys are so much smarter than I think you are. 36 raised to the 1/2. Any guesses at this? 6. So what is the 1/2 power talking about? Yeah.
I'm just gonna take this for a guess.
Okay.
But is it like the same number times the same number?
Okay, and that's known as what term? What?
Square.
The square. So we're taking the 1/2 power is taking the square root of a number. So the square root is what number times itself would give us what's inside the radical. Okay. So let's play around with this for a sec. Let me reduce. Let's reduce these real quick. I definitely want that. Let's bring this back up. My thing go away. I did what?
You need to make it longer.
Oh, you guys rock. There we go. So a number, a to the 1/2 power, is the same thing as the square root of that number. Okay, so perfect squares. 0 times 0 is 0. I like that. 1 times 1 is 2 times 2. 3 times 3. Keep going. 6. Keep going. Keep going. 36. Keep going. 42. Almost 49. 8 times 8. 9 times 9. 10 times 10. 11 times 11. 12 times 12. 69, 96, 225, etc. Perfect squares. So 0 times 0, 1 times 1, 2 times 2, 3 times 3, 4 times 4, all the way through. Anyone have a calculator out?
Yeah.
Want to see a little trick? Okay. Ready? Ready? You're going to like this.
Yes.
If I were to do 97 squared, I would tell you that the answer is 9409.
Yes.
Ooh. If I were, let's impress you guys. Let's do 102 squared. I'd say it's going to be 10404.
Yeah.
So cool. Let's do 93 squared. That's going to be 80, 86, 85, 49?
No,
No,
86.
49.
Oh! Darn it. It's too far away. Couldn't subtract. Yeah, moron! I'm more on than I'm off, so I'm not a more off, I'm more on. Sorry, I had to go there. All right, so just some of the perfect squares. I'd say those are the minimum that you should know. Yeah. The trick, so 97 squared. Ready? 97 is how far away from 100? 3. 3 squared is? 9. So 09 is my last two digits. Then I subtract 3 from 97. If I go above 100, like 102 squared, how far is 102 from 100? 2, because it's 2 above 100, you're going to add a 2 to it, so you get 104, and then you square 2, so you get 10404. If it was like 109 squared, it'd be 11881. So, just like that. All right, so that's just some of the ins and outs of what we're going to be working with this. All right, so know the perfect squares. That's important to know. Okay, if you don't know the perfect squares, realize that you're multiplying numbers together in order to get there. But then it says, use your calculator to find the following. 8 to the 1/3, 27 to the 1/3, 64 to the 1/3. So the last time it was 1/2, and that was the square root. So using the calculator, so we have 8 raised to the 1/3 power. You got 2? Oh, it's 86. Jeez. 8 raised to the, I was like, why did I get a weird number? 8 raised to the 1/3 power, you get 2. And then after that it said 27 to the 1/3 power. Anyone take a shot at it?
Isn't that
3, yeah. 27 raised to the 1/3 power. 3. 64 to the 1/3 power?
16?
Huh?
6?
6. Let's take a look. 64.
No, I'm sorry, 8.
8. Whoops. Clear. 64. 4. Come on, 4. Come on, 4. Yeah. Clear.
Oh, no, it's 4. Yeah, delete.
Go there. 64. Let's just happy about this. 64. There we go. Raised to the 1/4 power. Or 1/3 power. So someone said 8. I got 4. Alright. So square roots was a number times itself. Perfect cubes, let's see. 0 times 0 times 0 is? I'm pretty good with that. 1 times 1 times 1 is? I'm okay with that. 2 times 2 times 2. 2 times 2 is? 8. 3 times 3
27.
times 3 is 27. 4 times 4 times 4. 5 times 5 times 5.
125.
6 times 6 times 6. 216. Good. 7 times 7 times 7. 343. Good. 8 times 8 times 8. 512. 9 times 9 times 9. 729. 10, 10, 10 times 10. 1000. Okay, those are your perfect cubes. Now, I'd say it's probably pretty important that you understand perfect cubes, because if you start realizing the pattern that takes place, so any of those numbers raised to the 1/3 power. So if I did the 1/3 power of 8, I get 2. At 1/3 power of this, I get 3. 1/3 power of this, I get 4. 1/3 power of this, I get 5, 6, so on and so forth. Let's see, what is the next slide going to tell us? Now, how about 4 to the 1/2? How what is this? 4 to the 1/2? Did I just do that? No, it's 4 to the 3/2. Man, that's pretty bad. 4 raised to the 3/2 power. And then 8 raised to the 2/3 power. 4 raised to the 3/2 power should be 8. Did you get that on a calculator?
Yeah.
It should be 8. And 8 to the 2/3 power is 4.
Yeah.
Did you get that? Okay, so hang on. Let's see what you can decipher this. So if I had a number raised to the 1/2 power, this was the same thing as the square root of that power. Now, do I need that 2 right there, do you think? Or can the square root sign stand alone like this? What about it when I add it to the 1/3 power? I had this. Can this be the same thing? And could this be reduced to anything different? Or does this have to be a little 3 above the little check mark part of the root? So if x to the 1/2 is square root, x to the 1/3 is the 1/3, why are we getting 8 and 4 for answers when it's raised to a different fraction? Ideas? There's something more that's taking place. It's not just the 3 is taking place. So let's see. Maybe our next slide will take us on a further adventure. Ooh. Let's make that a little nicer so we can all see it. X to the m over n is the same thing as the nth root of x raised to the m, or the nth root of x to the m. These mean the same thing. So if I had 5 to the 3/7 power, how can I write this to look like, say, this? What do you think? So the example is x raised to the m over n, where that's the same thing as the nth root of x to the m power. So how would you write 5 to the 3/7 power as a in radical form? And I will tell you, 5 to the 3/7 power is just some nasty decimal that goes on forever. What do you think? Casey, what do you think? Yeah? I like it. Now help me out here. Let's link 5 to the 3/7 to x to the m over n. Which part of that would you feel x is part of above? Huh? Yeah. That's the same. M goes with what? 3. N goes with what? Cool. Casey, you're going to be first. Talk to me. I'm going to use this. What goes right here? Yeah, buddy. What goes right here? Yeah, buddy. And where does that go? Done. Good job. No quiz for you this week. Angela's, dude, I'm in. Huh. Let's see. So write each of these. So that, let me rewrite this. That's x to the 3 over 2. And that is
Y to the 1.
y to the 1/4. Your eyes are great. All right, so let's figure this out. So, all right, what's going to go up here? 2. What goes here? X. What goes here? What goes here? What goes here? What goes here? That's all it is. So we're taking an exponent, which is a fraction, and we're converting it back into a radical. Yeah.
Do we do anything further from there? I mean, do we?
You could.
Like, would you multiply like x to the 3rd and then square it, and then what'd you do?
You could. I'd say if it's a small enough number, if you had like 58 is your x value, and it's raised to the 7th power, yeah, I'd leave it like that, because your calculator is going to give you some weird answer this long. Let's see if we can apply that to some of these. All right. Rewrite each expression as a radical and classify it as an integer, a rational number, an irrational number, or a non-real number. Okay, so rewrite each expression as a radical. So 24 to the 1/2 power is the same thing as, what goes here? 2. What goes here? Okay. Someone for just the heck of it, what is the square root of 24? 12? No. No, because 12 times 12 is 144. What's the square root of 25? 5. So the square root of 24 is bigger or smaller than 5? Smaller, okay. What is the square root of 24? No. 4.5? 4.8 exactly?
No.
No? Read it.
4.8989799486.
Sounds like a pattern to me. What about you guys? Got a pattern there? No pattern? Doesn't have a pattern to it, so this has got to be listed as an irrational number. So that was a really long decimal that took place. It wasn't like 4.2. It had something going on. All right, 2 to the 1/2 power. Let's write it in radical form. Right? What do I do? 2 on the inside. Now notice I'm putting the 2 there. Technically, it doesn't have to be there. I like putting it there because we're doing the same trend. Square root of 2. Somebody. It's not 1. I'll tell you that. Square root of 2 is what? One 1.42, 1.5, 1.3, 6, 9, 12, 12, 16, sideways 8. Irrational. This is the square root of -4. So the square root of -4, if you do it on your calculator and not in the right mode, it's going to give you an error.
Yeah.
Right? So those of you who like to jump ahead a little bit, that's actually the answer to this is plus or minus 2i because they come in pairs. But this is a non-real number. Non-real just means it's not part of the real number system. You're like, what do you mean it's not real? Real number system labeled name. Okay, non-real. Oh, so I went 1, 3, 5. Sorry. Hey, 16 and the 1/2 is 4. So this is the same thing as the square root of 16, which is equal to 4, which that's an integer. Okay. The third root of 8 is 2. That's an integer. Oh, 4 over 25. That's the square root of 4 over 25. What's the square root of 4? 2. The square root of 5? So 2/5. 2/5 is a fraction, so that is a rational number. A rational number is a number that can be written as a fraction. Sweet.
Is number 4 1/3 or half?
It's 1/3. Okay, so you have rational numbers. Those are numbers that can be written as fractions. Integers, those are numbers that are just it's a whole number. It's a numeric value. Irrational numbers is if you take the square root and it fills up your entire screen and there's not a pattern to it. And non-real would be if you have the square root of a negative number. Now I just said square root of a negative number. So if you have 2 rational numbers, their sum will be rational. If I have 2 rational numbers, what's a rational number? A number that can be written as a fraction. So if I have 2 rational numbers, then their sum, meaning I'm going to add them together, is a rational number. If I add 2 fractions together, do I get another fraction? Yeah? If I get another fraction, it must be rational. I like it. And 1/2 and 1/3, for those of you that are sitting there looking at it, is 5 over 6. So that definitely works. If I have 2 irrational numbers, then their product will be an irrational number. Ooh. I have two irrational numbers. So we said square root of 2 is irrational, and square root of 3 is irrational. So if I were to take the square root of 2, 2 raised to the 1/2 power plus 3 raised to the 1/2 power. So that's the square root of 2 plus the square root of 3. Set it equal. I get 314,626,437. Gosh, that looks almost like pi. Pi is 3.141. But does 314,626,437 look like there's a pattern to it? So 2 to the 1/2 plus 3 to the 1/2. So the square root of 2 plus the square root of 3. They wanted us to say, if I have two irrational numbers, then their product will be irrational. Ooh, product. What does product mean, though? Multiplication. Okay. So I added those. I'm gonna go back. I'm gonna change that to times. Okay, this will be different. Oh, that's much better. So if I multiply, so if I added two irrationals together, I stay with irrational. If I multiply two irrationals, 2.449489,743. That looks like a pattern. Don't you think?
Yeah.
Really?
No.
Okay. 2.449489,743. I'm not seeing anything repeat. So I'd say if I multiply two irrational numbers together, then their answer is going to also be irrational. So irrational. Oh, I'm so good at this stuff. Let's see if I can influence you guys in a bad way.
Drugs?
No. Math. Worse.
Oh, Lord.
You guys good? You guys still good? You guys still good? You guys still good? You guys still good? What about now? 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 Still good? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. If you have a calculator, I need you to do this for me. Pick any two-digit number you want. Any two-digit number you want. Still with me? Do not tell me what your two-digit number is. And multiply it times itself 3 times. So cube that number. So if you pick like 25, it'd be 25 times 25 times 25. Does that make sense? Okay. How many digits is your number? 5 or 6? 6. Can you tell me what your 6-digit number is, please?
328,509.
509. Okay. Someone else have a 5 or 6 digit. Go ahead.
75, 35, 71.
Okay. Go ahead.
43, 89, 76.
Go ahead.
506, 53.
53. So a 5-digit number. Perfect. All right. Go ahead.
14, 80, 77.
Anybody else? Go ahead.
110, 59, 2.
Okay. Did I write the numbers down appropriately that you had? Give me. Okay. Ready? All right. I'm going to split each number where I will always have 3 digits on the right side. So it's going to be like that. Okay. Seem okay so far?
Yep.
Okay.
Is this how you do math so fast?
Yeah. Knew this one had to be 69. Yay?
Yeah.
Let's let's see, 3, so that's 91. Am I right?
What are you doing?
76.
Oh my gosh.
You get it?
Yeah, you did.
33.
37.
Whoa. Oh, 37. You're absolutely right. Small number to goof up on, I'll tell you. That's a 3. 148. 53. 92. That's an 8. 110. 48. Woo!
How?
Wait.
I just took the cube root of 5 and 6 digit numbers. Of course, I screwed up on the 5 digit. But. All right, ready? This is the trick. So at the beginning of this, watch this. Ready? Count with me. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Notice the last digit is one of the 10 digits, 0 through 9. Yay? So what we do is you split the number in half. You look at this digit. Whatever that digit matches up with, no matter on here, you go to that number. There's my 9. This number, 328, 328 falls between these two. So you go to the smaller. So this is a 1. The 1 goes with this. That's my 1 here. 753 falls between these two. So you go to that one. That's all it is.
Oh my God.
Yeah.
Can I take a picture of this?
Please do. Any of you want to take a picture? It's also recorded. All right, so your assignment this evening is worksheet number 20, which is on page 4142. Worksheet number 20. And remember, tomorrow, what I'll do is you get up to 4 points if you tried all the problems. Try mean all of them are right?
No.
No.
Sorry, what?
Yes.
It's extra, or worksheet number 20, which is page 4142.